solving systems of equations algebraically. So what that means is we want to find some value of both x and y that will make both equations work. When we have two lines, you're only going to either have one solution, no solution, or infinite solutions. And we did that in 5.4. And if we have a quadratic in a line, you can have up to 2, and same with a quadratic and a quadratic. So first thing you need to check out is what kind of system do you have. So this one we have a linear system, they are both lines. So we're going to substitute 4x minus 4 in for y so that we can solve for x in our system. So we have 2x plus 3 times 4x minus 4 equals negative 5. Now we're going to expand our brackets by multiplying. So 2x plus 12x minus 12 equals negative 5. Now we want to get our x's to the left side and solve for x. So we're going to move this over. So we have 14x equals 7, divide by 14, and x is equal to 0.5. So we know our x value. Now to solve for our y, we're going to substitute in for x into one of our equations. You could substitute into either one of them and it will work. So y is equal to 4 times 0.5 minus 4. Y is equal to 4 times 0.5 is 2, minus 4 is negative 2. So the point that satisfies our equation is 0.5 and negative 2. So when x equals 0.5 and when y equals negative 2. To test this, we're going to sub into the equation. And if it works, we know that it's our solution. So y, negative 2, is equal to 4 times 0.5 minus 4, and negative 2 equals negative 2. We already know this. 2 times 0.5 plus 3 times negative 2 equals negative 5. So 1 minus 6 equals negative 5. So this one works as well. So because it solved both solutions, we know that this is the answer to our solution of the systems. For this system, we have a quadratic and a line. And we know we have a quadratic because there is an x squared term. So we're going to substitute x squared in for y. So x squared is equal to x plus 2. And now we're going to put it into general form and factor to solve for x. So we need to move these to the other side. Oops, that should be a minus. So we need two numbers that add up to negative 1 and multiply to get negative 2. And our two answers are negative 2 and positive 1. So because this term is a, we know we have x minus 2, x plus 1. So x is either equal to 2 or x is either equal to negative 1. Now, because we have a quadratic and a line that crosses at 2 and negative 1, we know that this line is going to cross it somewhere 2 times. That's just a quick little sketch. So we're going to have two possible answers. So we're going to substitute both of our x values in to find our solution. So y equals 2 squared, so y equals 4. So for this point, our point will be 2 and 4, so x equals 2, y equals 4. And for this point, we have y equals 1, so x is equal to negative 1, y is equal to positive 1. To test this, test another one, we plug it into our equation. So this is equation A, this is equation B. So for the point 2, 4, for A, we have 4 equals 2 squared, which is right. And for B, we have 4 equals 2 plus 2, which again is correct. So this point works, it solves both of them. And for this point, negative 1 and 1, y, which is 1, is equal to negative 1 squared, so 1 equals 1. This works. And for b, we have 1 equals negative 1 plus 2, so 1 equals 1. So this point works. So these are our solutions. There's two possibilities. So for this one, it's again a quadratic and a line. We're going to substitute in negative 2x squared plus 10 in for y. So we have x minus 2 times negative 2x squared plus 10 equals negative 15. Now, when we distribute the entire negative 2 into our brackets. Don't forget the negative sign. So we have x plus 4x squared minus 20. And we're going to add 15 to both sides. So plus 15 equals 0. So we're left with 4x squared plus x minus 5 equals 0. Find our two numbers that add up to 1 and multiply out to get negative 20, and they are 5 and negative 4. So we have 4x squared plus 4x, minus 4x, plus 5x minus 5 equals 0. Split it into two groups. So we have 4x, x minus 1, plus 5, x minus 1. So our factored terms are 4x plus 5 and x minus 1. So that means, if we bring it back over here, 4x plus 5 equals 0, or x minus 1 equals 0. So x equals negative 5 over 4, which is equal to negative 1.25, or x equals 1. Now we're going to substitute to find our y values. So y is equal to negative 2 times negative 1.25 squared plus 10. And if you multiply this all out, you should get 6.875. So our point is negative 1.25, 6.875. And for our other point, we have y is equal to negative 2 times 1 squared plus 10. 1 squared is 1 times 2. Negative 2 is negative 2. Plus 10 is 8. So our point for this one is 1, 8. And they both work. I already checked them. If you wanted to check them yourself, substitute them both into the equations. Okay, for this one, we're going to substitute this in for y. So we have 1/3 x squared minus 3 x plus, equals 3. Now if we add 3 to both sides, we're left with x plus 1/3 x squared. So now we're going to take out a common factor, and to get rid of that 1/3 x squared, we're going to divide it out. So if we take out a 1/3 x, we're left with 1 plus x inside the brackets. So either 1/3 x equals 0, or 1 plus x equals 0. So x either has to equal 0 or negative 1. We substitute those into the equations. So I'm going to put it into this one. 0 plus y equals 3, so y equals 3. So our point is 0, 3, or negative 1 plus y. Oops, this should be a 3, not a 1. When you divide x by 1/3, it should come up with a 3. So that was my mistake. So it should be negative 3. There we go, now it makes sense. So negative 3 plus y equals 3. So y would have to equal it would have to equal 0. This should be a negative 3. So our 2 points are 0 and negative 3, or negative 3 and 0. I keep forgetting all these negatives. Okay, there we go. Now it's right. Sorry.